To add a data point to an orbital diagram, we use PowerPoint. So on the left, I have shown what we have measured to be the average separation from all of our images. So 5.654 arc seconds from the primary star to the secondary star, and then the average position angle, 63.871 degrees from north. Remember that north is down in these orbital diagrams. Now, what we need to do is we need to find a line or make a line that is 5.654 arc seconds long. You can see our x-axis down here at the bottom. If we go from 0 to 4, we'll know exactly how long that is. So I'm gonna just insert a line, okay, and I'm gonna zoom in on the image to make it a little bit easier, okay, and now I'm going to draw my line from as close to exactly 0 to 4 as possible. Okay, so now I have a line, and I'm just going to move that up so you can see it, that is 4 arc seconds long. Okay, we're going to change the size of that to make it 5.654 arc seconds. So what I'm going to do is right click on the line that I've created and go to size and position, and notice that it's 3.86 inches long. So it's 4 arc seconds on the orbital diagram, and on the PowerPoint screen 3.86 seconds. So we can figure out it's almost 1 inch per arc second. However, it's a little bit less than that. So we go 3.86 divided by 4 arc seconds, and that will give us the length. So 3.86 inches divided by 4 arc seconds equals 0.965 inches per arc second. Now we want 5.654 arc seconds, so we're going to have to multiply this number times 5.654, which equals 5.456 inches. So that's how long we need to make that line. Okay, so now we can click on the line again, and we're going to go to the size of the line. We can right click on that, size and position, and instead of being 3.86, we're going to make it 5.456, and it got longer. Okay, awesome. Now, one end of that line has to go where the primary star is. So you want to line that up as close to the center as possible. Okay, we can get that right on the center. And then we need the angle of that. So let's just scoot over there a little bit. Okay, we need the angle of this line to be our position angle. Let's scroll up just a little bit here. So our position angle is 63.871 degrees from north. So on this axis, we're going up not 90 degrees, but up 63.87 degrees. And you can kind of see from here, we're going to where our most recent measurement is. It's not going to be up at 90, so we're going to make this angle between north and our line 63.87 degrees. Now, when you're working it's going to do a rotation from the position that it's at. So I want it to be rotating downwards. I believe that's going to be a negative rotation, and it's coming from the 90 position. It's from east. So I did 90 degrees minus 63.875, and that's 26.129. So I'm going to make this rotation angle negative 26.129 and hope that works. I did it backwards. So let's undo that. And let's see. Make it positive 26.129. Now it's going in the right direction, and now I just have to move it. And And once we're there, we can put a little X marks the spot. We're gonna, oops, undo that. Make a little text box with an X, X, and we will put that right at the end of our line, right there, to indicate where our measurement fell.